Hello friends, welcome to Learner's Planet. Friends, this is our fifth session for set theory. In the previous session, we discussed the laws of union and intersection. We discussed the associativity, we discussed distributive property, commutativity. In this session, we are going to discuss De Morgan's laws, and these are very important. In your exams, in your written exams, maybe subjective paper, these laws may be asked to establish. Okay, so just get ready with your paper and pen and try to understand the things. To a certain extent, you need to mug up certain steps, but you should be conceptually clear also, right? So let's begin this session. Now, if A and B be any two sets, then A union B dash is equal to A dash intersection B dash. See, these are De Morgan's laws, and you can be asked, you may be asked in examination to establish these two. Okay, you need to prove that. So again, we'll start with an arbitrary element. Okay, we'll start with left hand side. We'll prove the left hand side is subset of the right hand side, and similarly we start with right hand side and we'll prove right hand side is subset of left hand side. So if both the sides are subset of each other, then both of them will be equal, right? So we start with an arbitrary element. Now X is an arbitrary element and of A union B dash, right? Now just follow step by step. X belongs to, because X is an arbitrary element of A union B dash, that means X belongs to A union B dash. Okay, now if X belongs to A union B dash, that means A union B dash is actually complement of A union B. That means what is happening, X doesn't belong to A union B, right? See, A and A dash are complement to each other. If X belongs to A, then X cannot belong to A dash, right? Suppose a set 1 or 2 is there, right? So complement, and this is set A, and set U is suppose 2, 3, 4. So A dash will be what? 1 or 2 will not be there, 3 and 4 will be there, right? So that is A dash. So if X belongs to A union B dash, that means X does not belong to A union B. Again, we'll convert this to, I'll open up the bracket. So X does not belong to A union B, that means X neither belongs to A nor belongs to B. If X belongs to any one of them, then also it will be part of A union B, right? So X should not belong to A, and simultaneously, not or, simultaneously X should not belong to B. Getting my point? If X belongs to either of them, then also X will belong to A union B, right? So if X does not belong to A union B, that means X should not be an element of A, and X simultaneously X should not be an element of B, right? If X is not element of A, that means X is element of A dash, right? And if X is not an element of B, that means X is element of B dash. That means X is element of A dash and X is element of B dash. Now we can replace this end by intersection. That means X is element of A dash intersection B dash, right? So that means what? We started with this X belongs to A union B whole dash, and we are getting X belongs to A dash intersection B dash. That means A union B dash is equal to is subset of A dash intersection B dash, right? A very simple conceptual explanation I am giving you over here. Okay, A union B whole dash is subset of this. Now we have proved that this is subset of this. Now we'll go other way. We'll start with this and we'll prove this is subset of this. This is subset of this. Okay, so once both of them are subset of each other, they will be equal. So we take the second part. We started from here and we got here. Now we'll start from here and we'll reach here. So I start with right hand side now. Okay, here I take an arbitrary element as Y. Now Y belongs to A dash intersection B dash, right? Just listen to me carefully. Y belongs to A dash intersection B dash. So intersection can be replaced by end. That means Y belongs to A dash and Y belongs to B dash. Now what is, if Y belongs to A dash, that means Y doesn't belong to A. Okay, and y doesn't belong to B, right? Because y belongs to A dash and y belongs to B dash. That means y does not belong to A or y does not belong to B. That means precisely y does not belong to A union B, right? If y is not an element of A union B, that means y does not belong to A union B. That means y belongs to A union B dash, right? If y is not an element of A union B, that means y is an element of A union B dash, or we can say A union B complement. Okay, and we started with y belongs to A dash intersection B dash, and we are reaching y belongs to A union B whole dash. That means this is subset of this. Okay, earlier we proved the reverse side. Now this is subset of this and this is subset of this. So that is possible only when both of them are equal to each other. Okay, so this is the first part of De Morgan's law, and that's very simple. You just have to apply common sense. Just write the De Morgan's laws 1 or 2 times. You should practice like this. It will be really cleared in your mind once for all. Similarly, we can take this part, A intersection B whole dash is equal to A dash union B dash, right? Again, we'll start with X, an arbitrary element. We'll prove this side is subset of this. Then we'll take this side and we choose an arbitrary element Y and prove this side is subset of this. Okay, so just go step by step. A intersection B whole dash. First of all, we establish this. So X is an element of this. So X belongs to A intersection B dash, right? So if X is an element of A intersection B dash, that means X is not an element of A intersection B, right? So if X is not an element of A intersection B, that means X is not element of A or X is not element of B. Okay, so if X is not an element of A, that means X is element of A dash. I'm sorry, not. Okay, so if X is not an element of A, that means X is element of A dash or X is element of B dash, because X is not an element of B. So if X is not an element of B, or we can say X does not belong to B, that means X belongs to B dash. Now we convert this OR to union sign. That means X belongs to A dash union B dash, right? So A intersection B whole dash, X belongs to A intersection B whole dash and X belongs to A dash union B dash. That means this is subset of this. Okay, that we have proved. Now we'll start from this side and we'll reach this side. So now I take a arbitrary element Y, and Y belongs to A dash union B dash, right? So Y belongs to A dash union B dash. That means Y belongs to A dash or Y belongs to B dash, right? Union replaced by OR. So Y belongs to A dash, that means Y doesn't belong to A and Y doesn't belong to B. Okay, because Y belongs to A dash or Y belongs to B dash. That means Y cannot be an element of A and Y cannot be an element of B, right? That means Y is not element of A intersection B and is intersection. So Y is not an element of A intersection B. That means Y is an element of A intersection B whole dash, right? So we started from this side and we reach this side. So this is subset of this. So earlier we proved this is subset of this. That means both of them are subset of each other. That means both of them are equal to each other. Okay, so that's pretty simple and very important, believe me. Next is involution law. If A, B, N is set, then A dash whole dash is equal to A. Again we'll start with X, an arbitrary element, right? Now X is an arbitrary element of A dash whole dash. Now this is just one entity and this is the complement, this dash is the complement of A dash. So if X belongs to A dash whole dash, that means X does not belong to A dash. If X does not belong to A dash, that means X belongs to A, right? So we started with A dash whole dash, X belongs to A dash whole dash, and X belongs to A. That means A dash whole dash is the subset of A, right? A dash whole dash is subset of A. Okay, similarly we can start with A, this side. So X, I take Y belongs to A. That means Y doesn't belong to A dash. That means Y belongs to A dash whole dash, right? So Y belongs to A and Y belongs to A dash whole dash. That means this is subset of this. Okay, so this is subset of this. This is also true and this is also true. So both of them are subset of each other. That means both of them are equal. As simple as that. Next is applications of set theory. The set theory can also be used in practical problems. Let us discuss the problems containing 2 or 3 sets. Suppose we have 2 finite sets. So number of elements A and B are disjoint, then there is no common element in A and B, then number of elements in A union B is equal to number of elements in A and number of elements in B, that is plus number of elements in B. If both of them are not disjoint, that means some of the elements are common, then number of elements in A union B will be equal to number of elements in A plus number of elements in B minus number of elements in A intersection B, right? Similarly, the other formula are also there. Number of elements in A union B is equal to number of elements in A minus B. A minus B is actually only A. If this is the representation, that's A, that's B, that is A minus B, that is A plus B, and this is A intersection B, right? So union is actually this plus this plus this. Obviously, so A minus B, number of elements in A minus B plus number of elements in A intersection B plus number of elements in B minus A, sorry. Only A intersection B, and only B. Okay, so that's pretty simple. Other formula can also be established. You don't have to mug up the formula. You should be cleared with the Venn diagrams, right? Once we start solving the problems, you will be cleared with Venn diagrams, and if you are clear with Venn diagrams, then you don't have to mug up the formula. Okay, similarly, this important one, for 3 finite sets, you don't have to mug up all the formula, just learn the formula for 2 sets and 3 sets. A union B union C, number of elements NA and B and C. Deduct intersection between A and B, B and C intersection, C and A intersection, and add A intersection B intersection C. Again, we will be using the Venn diagrams to solve the problems based on 2 sets and 3 sets. So no need to mug up the formula. Okay, you should be conceptually clear. Now I just elaborate the 3 set funda, that is A union B union C. Suppose this is the set A, set B, and set C. I have chosen 3 different color circles. Now just see, this is the portion that is common among A, B, and C. We call this, I just names areas so that will be better cleared in your mind. A, B, C, D, E, F, G, right? So C is the portion that is common among all the circles, that is A, B, and C, right? So C is actually A intersection B intersection C. Okay, C is common among all the circles, so it is actually common element of A, B, and C. Now B is only common between A and B, right? So B is actually A intersection B, right? And B, A intersection B only, right? And similarly between B and C, F is the common portion. Okay, similarly D is the common between A and C. Okay, now this is only A, that is only B, and that is only C, right? Now friends, while we write like this, now what happens, actually A intersection B is B, this, but A intersection B is this complete circle, this complete area. Okay, and B is just this portion, right? So B is actually A intersection B, but apart from that C is also a part, right? So A intersection B is not only B, but it is B plus C. Similarly, B intersection A intersection B is B plus C. Similarly, B intersection C. B intersection C is not only F but also C, right? So it is F plus C. Similarly, A intersection C. Intersection of this circle and this circle is D and C both. Okay, so what is happening if you add all the three, that is A intersection B, B intersection C and A intersection C, you are getting C 3 times, right? So I just try to elaborate the formula, and number of elements in A plus number of elements in B plus number of elements in C, right? Now what I do, these are the total number of elements. Number of elements in A, that means this entire circle, that is A plus B plus C plus D, right? Number of elements in B is what? C plus B plus F plus G. Number of elements in C is what? D plus C plus F plus E, right? So number of elements in A, number of elements in B and number of elements in C. Now you can see some of the areas are getting calculated double and triple times. Now double time calculation is for D, B and F. You can see D, B and F. One more D, one more B and one more F, right? So D, B, F, they are getting calculated 2 times. So to calculate the number of elements in A union B union C, if we write this statement, we deduct B, D and F. So minus B, minus D, minus F, right? Now B, D, F are getting calculated just once, okay? Because once we have deducted. Now what is happening? As I already told you, B is actually A intersection B. So B is nothing but B plus C. F is nothing but F plus C, and D is nothing. That means precisely A intersection B is B plus C, B intersection C is F plus C, and A intersection C is D plus C. So when we are deducting B plus C, F plus C and D plus C, C is totally eliminated. Okay, C is totally eliminated. So once we are deducting all these, we need to add one C. Right? So what comes up the formula? That is NA plus NB plus NC minus number of elements in A intersection B, number of elements in B intersection C, number of elements in A intersection C, plus, because the common portion, that is this portion, is getting eliminated, so once we are adding this, so this area, that is the element C, we are adding. Okay, so when we'll be doing the problems based on Venn diagram, you will be getting it very easily. Okay, do not get confused. A intersection B is this complete portion, right? That's why I'm writing down B plus C. Okay, basically B is only A intersection B but not C. Okay, so do not get confused. Now friends, let's see this problem. Number of elements in U 700, number of elements in A 200, number of elements in B 300, A intersection B is 100. We have to calculate A complement intersection B complement. So what I do is I just draw Venn diagram. That is the simplest way to solve the problem. This is a universal set. Then we have this circle A, and we have this circle B. Okay, now start filling A, B. Total of all is 700. We start filling from the common portion, that is A intersection B, that is 100. Number of element in A. So total of this circle is 200. So if 100 is here, 100 will be here. Right? and number of elements in B is 300, so 100 is here, 200 is here. Okay, now we have to see the common portion of A complement and B complement. So just listen to me carefully. You can do this problem using formula also, but how do you solve this problem using Venn diagram? That I'm just going to show it over here. Now you see, what is A complement? A complement is this entire area, right? Except this circle. Except this circle, the entire area is A complement. Okay, now there are total 700, so 200, 300, 400, that means 300 outside these two circles, right? Now we have drawn A complement. Okay, that is the area which is outside this circle. Now we draw B complement. I change the color of the pen. B complement, that is the area that is not part of B. So just leave the circle of B and shade the remaining area. Okay, so that is B complement. Okay, now you have to find out the area that is common between A complement and B complement. So you have to choose the area that is having the maroon shading as well as the purple shading, so that you can see outside these two circles, right? The area that's entire area that is outside these two circles is actually A that is the common between A complement and B complement. So outside these two circles, how many elements we have? 300. So A complement intersection B complement will be 300. As simple as that. Okay. Now if you used to wish to use the formula for this, so what exactly is happening over here? Total number of elements, that is NU. Right? From total number of elements, what we are deducting? The total of these two circles, that is actually 400, and these two circles represent A union B. Okay, so total number of elements minus number of elements in A union B will give you number of elements in A complement intersection B complement, right? Number of elements in U is 700, A union B is 400, so that is A complement intersection B complement. So I told you the formula also, and I told you how to solve the problems using Venn diagram. In case and in your exam, suppose you don't have double color pen or you don't want to use that, then you can draw the horizontal lines and vertical lines to show A complement and B complement. Okay, so when whatever the portion that is having horizontal and vertical line both, so that is the area common between A complement and B complement. Okay, so that's pretty simple. In the next session, we are going to take some more problems and do revise this session. All the theorems, that is proof that problems I have explained, that is laws, you need to write at least 2 to 3 times, because they may be asked in exams, and all the marks depends upon the steps. Okay, so do revise this session in the previous one. I'll see you in the next session once again. Bye bye.